Hello. I hope I'm still audible. Seems like so. Cool. So my name is Jayesh. I'm a principal solutions architect at StarTree. What we are going to do today is talk primarily about three things, right? One, we'll go on a small journey, look at how real-time analytics came into being. That is one. Second would be why do we care about real-time analytics, right? And the third would be what does it all mean in the age of AI and the changing world, right? How does this interface with the changing world today? So we'll go back in time to probably 2011 or so, and we'll go back to LinkedIn, right? You must have seen some of these pages back at LinkedIn, right? These is who's viewed my profile, your LinkedIn profile, so on and so forth. So LinkedIn had a huge problem back in 2010, 2011 phase, right? The platform was being used on an ad hoc basis. People were not coming back to the platform because it did not have any engagement drivers. It was more of a platform where people could just submit their, let's say, resumes and look out for jobs. What they wanted to do was drive engagement on top of this particular platform. And the brilliant product engineers back at LinkedIn came up with the feature which is who's viewed my profile, right? I can instantaneously look at your profile and you get a notification as well as, let's say, a metric which says how many people are looking at your profile, right? And humans being humans, this was an instant driver for engagement, right? People were very keen to know how many people are looking at it, who's looking at my profile, where do they belong, so on and so forth, right? So we'll go back and see how does that work back at LinkedIn itself, right? So this is 2011 or 29 to 10 kind of a time frame, right? So what happens in the background is whenever there is a metric that you're shown on LinkedIn, right? How many people have viewed at your profile? How many likes do you have on your post? This is what is actually happening in the backend, right? It is running an analytical query. Give me sum of or count of a particular metric where the time frame was XYZ and looked at by user, so on and so forth, right? But it is not just about the query that is running, right? What is beautiful is this is running at a scale that is unprecedented, right? Everybody today in this hall can open up LinkedIn page and still be able to look at those metrics. Everybody on this planet together can open up the same page and still be able to look at those particular metrics, right? So what we are talking about is nearly 930 million users. QPS, what we refer to as is queries per second, nearly 10,000 queries per second, and the latency of less than 100 milliseconds, right? Because it is a customer-facing application to the end consumers, there is no delay involved. It is not like a traditional BI where the spinner can keep widgeting out and the people will still be on your page. They will more likely abandon that page altogether, right? And this is what LinkedIn built. We'll go back and look at what the high-level architecture of that looks like, right? Basically, any event that happens on LinkedIn, right, in terms of me liking a post, me looking at your profile, or you just viewing a particular post itself, it generates an action which is then translated into a message onto a Kafka queue. This message is then ingested into a system that we are going to learn more about, which is Apache Pinot. But what happened with this entire pipeline is Apache Kafka reduced the cost per event, right? Now Kafka has become the backbone of our messaging systems. You can pick up any digital event or any real life event, translate it into a digital twin and push it via a streaming system like Kafka. What Pinot is trying to do is reduce the cost per query. The amount of cost that is needed to run queries which are internal facing to the amount of cost when it is required when tens of thousands of people are together on your platform and trying to execute that queries, right? That is how the birth of Pinot was back in 2013, 2014. It was formed back at LinkedIn and then open sourced around 2018 or 2019 timeframe. The question though still begets, right? Why do we care about fast OLAP? Why do we even care, or what is different between this OLAP system versus the OLAP system that we are looking out, right? I would try to think about it in two ways. One is the business phase, right? From a business perspective, analytics has always been logged internally. It has always been for internal users. It started with back in the day in 1980s or 1990s only for the CXOs. You get a T+1 report, CXO looks at what were the sales previous day, what were the invoices previous day, right? Moving from that, we went into a more batch mode where you are able to do every 15 minutes, every 1 hour, and all of your internal users are privy to that data, right? You have analysts figuring out what are the data patterns, you have operators figuring out where is the gold mine of data, where we can jump in next. However, the true power of data, how LinkedIn showed is to take that same data and push it back to your customers itself or to your partners itself, right? The data that I'm looking at it personally, my views, my likes, I am able to make informed decisions based off that, right? Which posts are circulating well, what content should I be writing, in what area, so on and so forth, right? So they took the power of same data and pushed it out in the back in the hands of their consumers, right? And that is a difference which brought in engagement for the platform all in all together. But again, this question still begets, what does it differ from a technical standpoint, right? Why can't the traditional systems or the current systems be able to handle that particular, let's say, scale that we are talking about? We'll be talking about 3 metrics back and forth. So the first one is data freshness, right? Data freshness refers to when the event has happened in real time to when the data is available in a system like Apache Pinot for querying. Again, if you are using a traditional data pipeline, an event which is there on the real-time system can take anywhere from hours to days to get into a system, then be available for querying, which is, of course, not the right way if you are doing customer-facing analytics. If I am making a payment right now, if I'm looking at a profile right now, that event should be available immediately for you to be able to understand the metric going up and down. That is what we refer to as data freshness. The next is query latency. Internal users are okay to refresh a Power BI dashboard, go for a coffee break, and come back again, right? It is okay if an internal Power BI dashboard takes 20 seconds, 30 seconds to refresh, or any Tableau dashboard takes that much time, right? But you won't allow same level of SLAs within customer-facing app. If your LinkedIn widget keeps spinning for 10 to 20 seconds, you will more likely than not abandon that page altogether and don't even use that particular feature itself, right? Hence, it has to be fast. It has to drop from seconds latency to milliseconds latency so that it is immediately visible as a new metric that you can browse or play around with. That is where the query latency comes into play. And the third important, let's say, the dimension that these real-time analytics platform differ on is the query concurrency, right? Or the user concurrency. Primarily, again, if it is for internal analytics, at max, you might have 100 operators, 100 analysts, or even 1,000 analysts. But okay, you can again take this on the other end of the spectrum. When you allow this data to be viewable by all of your partners or all of your consumers, the number increases manifold, right? It can be tens of thousands of users, or be scaling to millions of users. And the app has still to function in that particular latency with that particular freshness and still be able to provide insights which are available at the tip of your fingertips, right? So these are the 3, let's say, I would say, core dimensions. Whenever we are talking about real-time analytics or analytics in general, you would want to look at these 3 particular dimensions and decide where does your use case fit in, what is the problem that you're trying to solve, and if it falls into which of these categories, right? In which of these buckets, I would say. So coming to the answer back at LinkedIn, right? So LinkedIn team started using a platform which was based on Lucene index for powering this who's viewed my profile, right? But the amount of hardware required or the cost of hardware required was much, much greater than the ROI they were able to generate from the business case of who's viewed my profile as a feature itself, right? Which just makes the whole offering useless pretty much from a company perspective. Hence, they went ahead and built a system of its own, which is known as Apache Pinot. We'll spend a few minutes now to discuss about what Apache Pinot is. And yes, Pinot is actually a wine, and the name comes because the founders actually love wine, and that is why the name is Apache Pinot. Just a quick tidbit there. So Apache Pinot, in a nutshell, is a real-time OLAP database. It is basically a columnar database that is able to ingest data in real time. And when I talk real time, I don't say that chalega type real time. I'm talking true real time in the order of seconds. So whenever that event hits a Kafka topic, within a second, you can ingest that into Kafka. That is the data freshness that we are talking about. And then the other 2 dimensions are concurrency and the query latency that Pinot is able to solve, right? So it is a distributed OLAP data store used for analytics, which are primarily requiring these combination of these 3 particular dimensions in a higher order magnitude. And it is, of course, highly fault tolerant because it is being running at scale at LinkedIn and few other places. It is a distributed OLAP data store and columnar in that nature. We'll look at a traditional, let's say, a data pipeline or a typical data stack, right? So to typically know where does, again, Apache Pinot fall into all the gamut of that, right? So basically what you can see is this is the Apache Pinot, or this is where the Apache Pinot fits in. You have your source systems where the data is coming in from the left-hand side. What has happened is there has been all this effort spent to do change data capture, to capture the events in real time. But once you get the data in real time, currently it is still being pushed onto the batch-based systems. The problem with these batch-based systems is the latency required for the data freshness is always order of minutes or hours, depending upon your data pipeline. And the throughput concurrency is very, very limited, right? If you have your data already coming in with high momentum and high velocity in Kafka within seconds, why not store it in a system which is capable of ingesting that data in real time, rather than doing micro batching or doing some sort of batching and taking the momentum out of that particular data set itself, right? And that is where Pinot fits in. You can ingest this data from any real-time system, Kafka, Kinesis, PubSub, so on and so forth, and achieve the combination of these 3 metrics, right? the latency, the throughput, and freshness. And you will see what is the difference between the data lake systems. So when you have order of seconds or the freshness requirement of hours to days, it is much better to go with a data lake system than a Apache Pinot as a system, so on and so forth. So this is where from a traditional, I would say, landscape of analytics or a modern data stack, if I may, this is where Apache Pinot fits into play. These are some of the use cases that Apache Pinot is currently serving in production, right? So we talked about LinkedIn. Any number that you see on LinkedIn today is actually powered by Pinot. Similarly, Stripe. Any transaction that happens on Stripe globally is ingested via Kafka onto Pinot. And what they use it for their merchant-facing dashboards, right? Basically, you have merchants which are using Stripe as a payment gateway. Stripe provides real-time analysis of how many transactions have happened in the last 1 minute, what is the ARR looking like, what is the MRR looking like in real time, right? All of those dashboards. They have more than 1 million merchants that are using Stripe as a payment gateway, right? All of them can log in simultaneously, still look at a real-time data and be available to that. Similarly, any number that you see on Uber Eats or Uber as an app. So for example, Uber Eats, which is of course not available in India right now, but any geo-fencing query, right? So if I'm searching for pizza within 5-kilometer radius, that search is also happening with using Apache Pinot. So Apache Pinot has a geo location or a geo index primarily used for that. And again, the important part is to note the latency of it, right? Like all of these are customer-facing applications. So latency is 25 milliseconds and not seconds, and similarly, it is less than 100 milliseconds. That is the order of magnitude. It is actually just slightly longer than the blink of eye. The blink of eye is 20 milliseconds, if I understand. This is just 25 milliseconds. So if you just blink your eye, you will see the dashboard get refreshed. What about back home in India, right? So these are some of the customers who are already actually using StarTree or Pinot at the moment, right? So any transaction that you do today on Razorpay actually goes via a transactional system onto Kafka, onto Pinot together. And they are powering it or they are using it for multiple use cases. One being their merchant-facing dashboards, looking at Stripe. And then there are certain microservices aggregation use case, right? Basically, they compute something known as a success rate to be able to figure out which is the payment method working best at that particular instant of time, which payment method has certain failure rates, so on and so forth, right? Similarly, any order that you do on Blinkit today goes via the same system. Each dark store then basically gets a real-time dashboard of how many drivers are active, how many drivers are inactive, which SKU has what sort of inventory, what is our average delivery time, and all of the metrics available to them in real time, right? So each and every order on Blinkit, as well as each and every delivery on Porter actually goes through the same ecosystem and goes back into Pinot for their customer-facing or their partner-facing dashboards primarily. Now, we'll take a slightly step pause, right, and take slightly a longer view, right? So back in 2022, I believe, 30th November 2022, our world changed slightly, right? ChatGPT was born, and post that, the things have changed slightly. Just like retirement of Virat Kohli brought an end of an era, this, I would say, brought a different era to begin with, right? Now, what we'll do is, again, we'll spend a couple of minutes to just unpack some of the keywords which are associated with this, and then we'll come back to the real-time analytics and how that piece tie-ups together, right? So the first is just want to quickly differentiate between an automation, an AI workflow, and an AI agent primarily. So all of those are used interchangeably very loosely, but all of those are different, right? Your automation is your classic automation. If this, then that, right? You have strict logic. You know the input that you're going to pass. You know the output that is going to come in. This is very, very useful. The best work done is where you don't need an AI. If you're able to handle your Boolean logic, go ahead and do automation. AI workflow is the second part of the ecosystem, right? Where the LLM call or an work by an AI agent is just one step of the process. So if you have 5-step workflows, only a couple of steps are part of the, let's say, the LLM calls that are happening. The rest of them is a Boolean logic. So the AI workflow is where you're mixing a combination of Boolean logic and a fuzzy logic. This is useful where you want the LLM to perform some of the actions, but not all of the actions, right? And that is where AI workflow comes into play. The third is the AI agent. Now, AI agent has complete autonomy. The AI agent works in a different way. You are basically giving a set of tools, giving it a set of permissions, and allowing it to perform the task for you in an undefined manner. You are not defining the quantum of steps the task should take to be able to achieve its output. You're just basically defining what is the output that you're needing. You're giving it the right tools and the access to environment. It goes on to a continuous loop, takes an action on an environment. If it needs to, takes the human feedback back into an LLM and keeps on this loop unless it has exhausted a certain set of attempts or it has been completing able to task, right? So just a quick, clear differentiation between automation, which is the Boolean logic, the AI workflow, and the AI agent piece, right? But how does it tie up with the RTA or the real-time analytics that we are talking about here primarily? Just before we do that, these are a couple of the building blocks which go into either one of those pieces, right? Either the AI workflow or the AI agent, right? So you have an input that is going into an LLM, and there is an output that is coming in. The LLM in turn has access to 3 or 4 things. One is retrieval, right? The standard retrieval augmented generation, right? You have basically textual data which you have converted into a vector. And for your LLM to know the context of your real-time data, you go ahead and retrieve the current set of vectors, provide that as a context to the LLM so that the responses are much more accurate. So retrieval sort of becomes a one armor in the LLM's chink. The second is memory, right? So, and the memory is divided into short-term memory and the long-term memory. Short-term memory is what is the context of the current conversation I'm having with the user. Basically, the current context window that the user has. Long-term memory is what is the memory of the user across different sessions, right? So if I'm having 10 different chats with OpenAI, what is the memory across that? And OpenAI has actually just released this long-term memory. It knows about your history of all of your chats, and you can actually ask it about what are my strengths, what are my weaknesses. You should try out. That is pretty fun to do. And then finally, to act on the real world or the digital environment, the LLM has access to tools, right? So if the LLM is poor in math, you give it an access to a calculator. LLM does not have access to the current information, you give it access to a web search. And similarly, the other forms of tools that it can do, right? So these are some armors available with the LLM to be able to go ahead and perform the task that it needs to primarily go ahead and perform. So how does it tie to Apache Pinot or the real-time analytics, right? So what we are seeing is the shift. We talked about the reports data, and then we talked about the data apps, right? The apps that are available directly within the applications itself, like LinkedIn, Stripe, Razorpay, so on and so forth, right? But from that, we are seeing a quite shift to conversational, let's say, response or conversational request, right? So rather than a single person, again, looking at the dashboard, it is more of conversing with the data. So that is the change from the data apps to conversational apps, right? People want to even talk to their data, get the insights, or even let the agent figure out the insights, right? You give me the raw data, ask the agent to figure out, okay, what are the top insights, which post will work better, so on and so forth, right? So this is a slight shift that we are seeing. The agent, the conversation has to be real time, as well as be a conversation in that particular nature. So again, you can again imagine from a different perspective, right? If there are 1 billion or 1 billion approximately humans who can open up a LinkedIn page together, assume everybody has an agent together, right? That is where the future is going, right? Assume everybody has an agent. Assume there are multiple agents for an organization. When all of these agents combine together and want to query a system, the system should still be able to handle the SLA of the response as well as the concurrency of the queries that are coming in from the agents, right? Hence, the agent or the swarms of agent require the same SLAs that we were earlier talking about, right? The similar data freshness, because an agent is useful if it is working on a day-old data. It needs the same, let's say, SLA 100 milliseconds, 200 milliseconds. But more important than that, hundreds or billions of agents need to simultaneously query the same data and still be able to get response within that, right? And that is why something like Apache Pinot goes and makes a good use case for this. We have actually added vector index support in Apache Pinot as well. So Apache Pinot is a database which is known for its indexing capability. So vector index is just one of the new indexes that is added. So you can actually do cosine search similarity using hierarchical small words navigation algorithms. So you can actually take a text, convert it into a vector using any one of the algorithms, push it into Pinot and do a search. But what is more powerful about this is you just don't want to do a vector search, right? Vector search is just one part of it. You will typically want to query the system on the other dimensions as well, right? What is this text similar to? Where is the user coming from? Which pin code? And contextualize more, right? And that is where the power of the other indexes comes into play, right? You can create a combination of not just, let's say, Apache vector index, but the combination of other indexes as well, which allows faster querying of data. We are able to pinpoint to the data that is needed at a much faster pace, reducing the quantum of work done per query. And that is how we are going ahead and reducing the cost as well. Apart from that, from a conversational perspective that I talked about, so this is a model MCP protocol, right, released by Anthropic in November 2024. So we have built out a layer, which is the MCP layer, which can actually go ahead and converse or use Pinot as a tool. So there is a conversation which can happen via Cursor, Claude, or any of the clients, which can go to a MCP protocol for the translation from text to SQL, push that SQL onto Pinot, get the responses back. So there is a thin layer that we have built out. It is actually going to be available in open source pretty soon, but you can actually do a conversation right now. And if time permits, I'll do a quick demo of the same as well. And this is continuing on the same thread of the real-time RAG, right? Again, if you want to do retrieval augmented generation, it is important that you're able to get the data in real time, convert that into vectors, and do a vector similarity search. You don't want to, again, fall into a, let's say, a batch-based mechanism where you are taking bunch of textual data, converting it to vectors, and then doing that. You pretty much want to do it on a real-time basis because the real world is moving in that world, right? You are basically twinning that system onto a Kafka queue. So the ability to do real-time RAG is basically due to the upserts mutability which Pinot allows, right? You can actually take a order status or an order payload and mutate that continuously in Pinot at a record level rather than at a later level, which is again very, very different to how other, let's say, OLAP systems work, right? You create a merge on later. So this is the shift we are primarily seeing, right? We are going from random intuition based to the consumers, users, and then finally agents. But the common pillars of both of them are still those three dimensions. Everyone wants fast data, everyone wants real-time data, and the ability to have concurrent access to that particular data and still be able to perform within that SLAs, right? Believe me, there will be agents which each one of will have, which will be running these queries on a system like Apache Pinot, expecting responses in that particular fashion. I'll just spend a couple of minutes now talking about what is StarTree. So Apache Pinot that we talked about is the open source technology. It is, of course, available for you to download, play around with, so on and so forth. StarTree is the company which is behind the open source project and helping manage the open source project, and I'm the principal solutions architect at StarTree. So what StarTree does is a bunch of things on top of Apache Pinot. So from features like upserts, from features like cloud tiered storage, right? Basically, you can define, okay, this is my hot data, keep it on SSD servers. This is my, let's say, warm data, keep on EBS servers, and then rest of the data on the, let's say, tiering system, right? You can create a tiering system. So that is cloud tiered storage. And the scalable upserts in terms of using off-heap upserts to mutate that data at a very, very large scale. So you can actually go ahead and deploy the core Pinot on your platform, on of your cloud of your choosing, right? So there are multiple deployment options that we can go ahead and do it. We can actually do a traditional SaaS model. You can basically deploy it on our system. Or we can do a combination of bring your own cloud, right? Basically, you can tell me, okay, this is the infrastructure that I have. This is the AWS environment. This is the GCP environment. And we will deploy a complete managed offering on your system. The data plane remains within your infrastructure. The control plane remains on StarTree. So it is complete managed offering. And apart from that, on the private preview, what we have is bring your own Kubernetes. So if you just have a EKS cluster or a GKE cluster, you can just give us access to that cluster and we'll deploy the complete application for you. And still being a managed offering, we will manage the complete deployment for you from that perspective. And of course, this is available across any of the clouds which you want to go ahead and deploy on. So this is again, a high-level architecture. So on the left-hand side, you have connectors. So Pinot has connectors for doing ingestion from real-time sources as well as some of the batch sources. The new feature that we are adding in terms of an AI capability is auto-vector embedding, right? So we are calling this as an enrichment. So if you can tell us, okay, this is the textual data that is coming in, and I want to create vector out of this textual data by calling an open API, OpenAI APIs, you can directly do that within the Pinot ecosystem as well. So you can just point to the table, point to the column, and we can do that vector generation for you and store that vector for you. So that is where the auto-vector embedding comes into play. And then on the storage front, right, you can choose, as I was mentioning, how do you want to tier your data? You want to use open table formats, or you want to use Pinot's formats for the best or fastest access? You can go ahead and do it. Where do you want to store that data itself? You want to store it on a data lake or on the servers, and then finally converse or get the data out either using the broker APIs, traditional BI tools, or go via the conversational Pinot agents, right, using the MCP protocol. So this is, again, a quick, I would say in a nutshell, what the architecture looks like. So I'll go on a demo, but before that, I just want to tell about what is the demo looking like. So basically, I have some data, which is the blue sky data or clickstream data that is coming in via a Python application, simple Python application. I'm pushing that real-time data onto a Kafka layer. Apache Pinot, as I mentioned, has a connector to the Kafka layer in itself. So Pinot is ingesting this data in real time. And then what we'll do is we'll actually use an MCP agent right now to converse with the data which is actually sitting in Apache Pinot and then be able to talk to it. Claude is visible, right? Awesome. So this is, just for context, this is the Apache Pinot UI, where you can, of course, run standard SQL queries, right? So if you were ingested some data into Pinot, you can actually go ahead and run certain sample queries on each one of these tables that we want to do, right? But what I have done is I've taken my Claude agent or the Claude UI, I've connected it as a tool to Pinot, the Pinot deployment that I was just talking to you about. So if you just go ahead and see, you will see a Pinot MCP Claude, which is what the integration that we have built out. So what we'll do is we'll actually chat with the data which is sitting onto Pinot today, right? And please bear with me, as I mentioned, my job is on the line. This is an LLM, so it might hallucinate, and it might go off fire. Then I'll go off script as well. So I'm starting with a basic question, right? Can you help me analyze my data into Pinot? Maybe just start by listing the tables, right? So we know it has access to Pinot, and it can then go ahead and list all of the data. So you can see it is actually doing a tool call right now, and you can see there is a JSON response. And these are the similar tables that we saw into the other platform itself, right? So these are the tables that it was able to go ahead and sort of bring that together for me in a chat form, right? Now I can go ahead and actually ask to chat with it, right? Again, I'm being slightly vague here. Just want to show you a couple of capabilities. The abilities it has to, for example, to first of all connect. And I did not give it a very specific name. There are multiple tables of clickstream. So it will go ahead and first look at what is the clickstream table looking like. It is smart enough to then figure out, I just need to do a select star to figure out what is the structure of the table itself looking like, right? What are the columns? How can I do a time-based analysis? And then I've been slightly vague in terms of just telling it to do a time-based analysis. So it will go ahead and actually run a bunch of queries, right? This is the true example of AI agent. The output is not determined here. I am asking it a vague operation to be performed. So it is actually, you can see running a bunch of queries on it and getting the response out of it, right? It has actually already done a pretty good job of analysis using epoch timestamps and getting back so on and so forth. So it will actually go ahead and keep running a bunch of queries. So what it is actually doing in the backend is taking my inputs, deciding what needs to be analyzed, right? It is not that I have told it. I have not given it the response of what are the columns, what analysis it needs to do, and still be able to write queries which are Pinot compatible. Even if it fails to, with a certain syntax, it will actually auto-correct itself, go back to Pinot, and then get me the response back itself. Right? So you can see, based on the clickstream data, it has done some sort of analysis of date-wise, right? How many each events are actually available on each one of these particular dates. And it has actually done a bunch of other analysis as well, the screen navigation, user engagement, so on and so forth. Yeah, and this is just me showing off Claude here, nothing to do with Pinot, but what it can do is, it can go away with that whole ecosystem of, okay, traditional database and then having a BI layer on top of it. I'm able to generate everything in real time. It is just that my database is capable of running those parallel SQL queries, understanding, and if I have the latest data in that database, I don't need a BI layer on top of it. I loosely don't even need a base analyst to start with. I can ask it to do analysis of its own and then run a bunch of queries and then generate dashboards out of it, right? So what it is actually doing right now is generating a dashboard for me, which is across reusable across. So this is coming back to the MCP protocol and the conversational AI part that I was talking to you about, right? Everybody today can go ahead and still be able to converse with this particular platform, just having the access to real-time data and then the ability to do, I would say, real-time analysis. So you can see it has actually gone ahead and created a very beautiful set of charts for me with all of the data and including different types of, let's say, analysis on top of that particular data. So just in conclusion, what I would like to go back is on the topic that so if you don't remember anything about the presentation, just remember 2 or 3 things. One is about Apache Pinot. Apache Pinot is a real-time OLAP database. The 3 dimensions always that are important is query latency, the data freshness, as well as the query concurrency. Pinot as a system is designed for doing real-time analytics when you want millisecond response time for hundreds or thousands of your users. You can use it to pair for a conversational AI or for your traditional dashboarding tool as well. And StarTree is the company which helps manage the open source project and, of course, helps you manage the deployments as well as built up a bunch of other features on it. With this, that was my time. Thank you very much. And I hope this was useful for you folks.